Before we continue, a quick and humble request to all of you. Please do share my videos with your friends. If you have benefited from it, please do share along and please do subscribe to my channel. And if you have found these videos helpful, please do hit the like button. This would mean so much to me. Now, the question 19 is about probability. It's mainly about the independent and dependent events. Let's look into this problem. Omari has two pairs of red socks and two pairs of white socks in a drawer. He has a drawer with two red t-shirts and one white t-shirt. If he randomly chooses a pair of socks from the sock drawer and a t-shirt from the t-shirt drawer, what is the probability that he gets a pair of red sock and white t-shirt? Now here there are two things, that is socks and t-shirts. First of all, are these dependent or independent? Now, dependent means if you choose something from here, it's going to affect the probability of the next one. Now, if I choose a socks from the two red socks, if I choose one, will the t-shirts be affected? Will it reduce or increase? Absolutely no, right? It's going to be the same thing. So here these are independent, in the sense they are independent variables, in the sense whatever you do over here, the probability does not affect the other event's probability. So now let's take it one at a time. First of all, the probability of A and B for independent events is very easy. It's probability of A multiplied by probability of B. These both are not affected at all. Now here, see, we need to find what the probability that he gets a pair of red socks and white t-shirt. Now, how many red socks and how many socks are there in total? Let's see the probability. The total outcome divided, the desired outcome divided by the total, right? So it's always desired, it's D, desired by total outcomes. Now here, how many are there? There are four socks because he has two pairs of red and two pairs of white. That means four is the total. But what is desired? What do we need to find the probability of? The red socks only. So it's 2 by 4 multiplied by how many t-shirts are there? There are two red t-shirts and one white t-shirt. That means total three t-shirts. And what is being selected? White t-shirt. That is 1 by thirds. So you simplify this. That will be your answer. It will be 2 by 12 or 1 by 6 would be the answer. So this is, you can just put in the calculator and solve for the probability. Just put in the calculator, multiply by 100, you will get the probability. It's 17%. It's 16.67, I guess, approximated to 17. So this is how we solve it. Let's look into some other problems now. Here we have Phyllis drops a penny in a pond and then she drops a nickel in a pond. What is the probability that both coins land with tails showing? So the coins, both are coins, each have the probability of 1 by 2, 1 by 2. Now she's not going to drop the same coin or something. Even if she drops the same coin, the probability doesn't affect. If she has two coins she's dropping, the probability of the first one is 1 by 2, second one is 1 by 2. So it is 1/4 or 25% would be the answer. Very simple. So this is the probability equation. Now if you're thinking what do we write, let's go to the previous problem. It's very simple, right? So you can just write the formula in detail. Write what is probability of A. Probability of A is Omari getting a pair of red socks. Probability B is Omari getting a white t-shirt. So that can be written out. And then put the formula, substitute and solve, because this is in writing part. Same thing over here, write both the events and then use the formula and solve it up. The third one is a die is being rolled and a penny is being flipped. So it's same thing, you need to find the probability of the die and the penny. So the probability of A, what is the probability? A 2 will be landed. 2 is 1 by 6 and a tail 1 by 2. Very simple problems. Please try them by yourselves now. Now let us go through this problem here. A marble contains 3 red marbles, two green marbles and 4 blue marbles. A marble is drawn randomly from the bag and replaced before a second marble is chosen. Find the probability that both marbles are blue. Now, here, this is a very important sentence, replaced. Now, replaced means you choose something and put it back. So the probability is not affected. This is also independent event, independent. So in your exam, please make sure you write this sentence. This situation is an independent event. This event is independent or something like that. Okay. And now, what is the probability that both marbles are blue? What is the total marbles? 3 plus 2 plus 4, right? It'll be 9 over here. And what is the number of blue marbles available? There are 4. And even the second time, it's again 4. Why? Because after taking the blue marble, that's put back, right? So this would be the answer. 4 by 9, 4 by 9. That's it. Then put in the calculator and solve it. This is independent events. Now, here again, it's a very simple one. Please do try to solve it by yourself. They have told the probability of the rain on 2 days. And what is the probability it will happen on both the days? Just multiply those probabilities. That's it. 40% is 2 by 5. 60 is 3 by 5. You're multiplying them. You'll get the answer. Now determine whether these events are independent or dependent and explain your reasoning. Now let's read through these problems. You roll an even number on a fair die and then spin a spinner numbered 1 to 5 and it lands on an odd number. Now look here, you're using a die and then you're using a spinner. Are these both at all related? No, the die is something separate, the spinner is something separate. These probabilities are just not affected, right? So this is independent. These are independent events because the two events have no bearing on each other. That means they are not affecting each other. Now, what about this one? An ace is drawn from a standard deck of 52 cards and not replaced. Then second ace is drawn. Now this is important. See, not replaced means you have 52 cards, right? And you draw a ace out. So you take that away. You're not putting it back. So now for the next time, out of 52, 1 is reduced. It becomes 51. In the next turn, when you're picking another ace, there are no 52 cards anymore. There's only 51. So it's reduced by 1, isn't it? So this happens. And now again an ace is drawn. So the probability over here would be, there are 4 aces. 4 by 52 multiplied by, now 1 was drawn. So there are 3 more and 51. This is the probability. But they're not asking the probability here. They're just asking whether it's dependent or independent. Here it is a dependent variable. So the answer is dependent. And you can read through it. And what about this? In a bag of 3 green and 4 blue marbles, a blue marble is drawn and not replaced. When you read the sentence "not replaced," you should know this is dependent variable because now it's not replaced. When you draw another blue marble, the number of total marbles initially was 7. Now it changes to 6 in the second try. So it is dependent. Now, you roll 2 fair dice and roll a 5 on each. Now, see, the dice are not at all related to each other. Like, I mean, you put any number in one die, in the other die, it's all again separate probability. It's 1 by 6 itself. It's not going to affect each other. Whichever number you get in one die, it's not affected. It is independent. So, this is independent. And now we have some more problems. So it's about lottery. Mr. Hans places the names of 4 of his students, Joe, Sophia, Hayden, and Bonita, on slips of paper. From these, he intends to randomly select 2 students to represent his class at the robotics convention. He draws the name of the first student, sets it aside, and then draws the name of the second student. What is the probability he draws Sophia and then Joe? Now, here it's very important to know that this is dependent. Why? Because he is going to pick a student's name and then keep it aside and then pick one more. So, what's happening here? Let's understand the situation. There are 4 total students. Okay, total number of students are 4. First, when he chooses one student. Now imagine that is the probability of choosing Sophia. That's 1 out of 4. But now, what is the probability of the next student? Just imagine for an instance that there are 4 students, right? If you're choosing one, what is the probability? What is, say, probability of Sophia being selected? It's 1 by 4. That's it. But now Sophia's name is gone. It's removed. Now there are only 3 students. So the total number of students remaining is 3. Now Joe is being selected. One Joe, that's it. So 1 by 4 into 1 by 3, just solve it up, it'll be 1 by 12. That would be the probability. You need to understand this is a dependent event and then we do it. 1 by 4 times 1 by 3. That's the answer. It's about 8%. So please make sure you mention this as a dependent event as well. Now here we have a card that is being drawn from a standard deck of playing cards and is not replaced. Then a second card is drawn. Find the probability that the first card is a Jack of Spades and the second card is Black. Now first card which is being picked, Jack of Spades. There's only one Jack of Spades because there are 4 Jacks in total but only one Jack of Spades divided by 52. Standard deck means 52. Now, what is the second probability? It's dependent because it's not replaced, right? Now, it's not replaced. It's clearly mentioned. That means now in the next probability, it will be 51 cards. Now, what is the probability it is a black? Now, sometimes we tend to think, oh, it is 26 because there are 26 cards in the black suit. This would be wrong. Why? Because one card is already removed out, and that was Jack of Spades. That's a black card. So it'll be 26 minus 1. That is 25. Why? Because there are total 26 black cards, yes, but already there was one card, Jack of Spades, removed and not replaced. So it's 1 by 52 into 25 by 51. That would be the answer. So it's 1%. And now here we have a table. It's the same thing, similar problems. The table shows the color and number of jerseys available for intramural volleyball tournament. If each jersey is given away randomly, what is the probability that the first and the second jersey given away are both red? Now, they're giving away. That means it's not gonna be replaced. So it's going to reduce it. First, find the total number of jerseys. Now there is 20, 40, 50, 60, 70 total. And which are being given away red both the time. So it is 25 by 70, but next time it will be 24 by 69. Why? 25 red jerseys divided by the total number. Now next time again it's being red, so it will be 25 minus 1, that's 24, and it is 70 minus 1, it's 69. So the probability is 12%. This problem looks interesting. I'll solve it up over here. The format used to determine an overall champion varies by sport. One type of format used is the best of 7 series, where up to 7 games are played and 4 wins determine a champion. If you assume that each team has equal chance of winning each game, what is the probability a team winning the first 4 games is best of 7 series? Now here you need to understand this sentence. If you assume that each team has equal chance of winning, so this is not dependent, it is basically independent. Okay, so all you need to do is independent, 50%, right? Equal chance means 50%, it's half. Just multiply half throughout. How many? 4 games, right? Half, 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 half. It is 6.25% chance of winning. That's it. We know that equal chance means it's 50% or 1 by 2. It's like tossing a coin. Now, how many games are being played? 4 games. So multiply it by half, 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 half. It'll be 1 by 16. There is another interesting problem about business. A sales management team consists of 3 directors and 3 assistant directors. To ensure that each team member has an equal chance to be chosen to represent the team at a national level, national conference, all the 6 names are placed into a hat and 4 names are drawn at random. What is the probability that those chosen will consist of 3 directors and 1 assistant director? Now here first thing is probability that this will happen, right? What is the total possible outcomes? Now here you need to understand there is no order required. Now there are six names and four are being chosen. It's going to take a long time to find the total possibilities, so we'll use combination. N is 6. The total number of names are 6 and we need just 4. So 6C4 is the total outcomes that is possible. We want the probability of 3 directors and 1 assistant director. Originally there are 3 directors and 3 assistant directors, but we just want all the 3 directors and only 1 assistant director, right? So what is the desired outcome? Now these can be written like this. There are 3 directors and all the 3 directors are being chosen. NCR, that is C3C. But how many assistant directors are there? 3 are there, but only 1 are being chosen. So 3C1. Now we can solve this up using formula or by calculator. If you're using formula, NCR is given by n factorial by r factorial into n minus r the whole factorial. Yeah, okay, whenever the same numbers. But over here, what happens is it'll be, you can solve it, it'll be 3, I believe. Yeah, it'll be 3 factorial by, what is r? It's 1 factorial. Then over here, there is 2 factorial, n minus r, right? So 3 minus 1 is 2 factorial. It'll be 3 times 2 times 1 by 2 into 1. This cancels. You're remaining with only 3. Now here you can use the formula. I'll show the calculator method in a minute. So here it'll be 4 factorial into 2 factorial as well. So what happens? 6 times 5 times 4 factorial. And over here we have 4 factorial. It cancels. And 2 factorial is 2 into 1. This with this, 5 times 3 is 15. So the probability is 3 by 15. Now this is divisible by 3, so 1 by 5. It's 20%. So that is the probability that this particular arrangement, the directors, 3 directors and 1 assistant director will be chosen. So we can see over here, that's the answer. Over here they have written each things in one step. Now you can just refer to what I have written. It's always desired outcomes divided by the total outcomes, right? Just do this and you'll get the answer. I'll show in the calculator now. All you need to do is to use combination. See, it's shift and the symbol over here. So you can use anything. C, 6, C4. That's the answer. If you want to write the entire thing, it's fine. You just use this and write 3 over here, C3 multiplied with 3C1, and you can write the same thing down. It is 6C, sorry, go down. 6C is by shift and division symbol 4, and the answer is 1 by 5. And if you want to know in terms of percent, you just multiply it by 100, it will be 20%. Another interesting problem. I'll just quickly go through this. Iris performs a magic trick in which she holds a standard deck of cards and has each of 3 people randomly choose a card from a deck. So standard deck means 52 cards and 3 people are choosing the random cards. Each person keeps his or her card as the next person draws. Now this is important because a card is taken and it is kept with that person. It's not being replaced. So it's dependent via probability, dependent event. What is the probability that all 3 people will draw a heart? So now we need to write what is the probability of heart being chosen in a standard deck of card. It is one suit, right? It's 13 cards divided by 52. This is the probability. When the first person draws, this will be the probability because there are full cards, 52 standard cards and 13 are hearts. But now when the next person draws, one of heart is drawn, so there will be 12 by 51. And even the third person is drawing a heart. So it's going to be 11 by 50. This is it. Put in the calculator, you will get the answer. You can write it as PA, PB, and PC and then solve it up the way you can see it. So remember, as more cards are being drawn of the same suit, it reduces 13 to 11 and even the total number of cards 52, 51, 50. So it's 1.29%. Here we have another problem. The probability that a student takes a geometry and French at Seoul school is 0.064. The probability that a student takes French is 0.45. If taking geometry and taking French are dependent events, What is the probability that a student takes geometry? Okay, you need to write the formula for dependent events. I'll just write over here P of A and B is equal to probability of A, but what is the next one multiplied by the probability of B condition A, right? Condition that this A has already occurred and this probability changes. So we don't write just P of B. If it was independent events, we just tell probability of A and probability of B. But since they are dependent, we write this as the formula. Now here, A is say taking geometry and B is French. The probability that the student takes geometry and French at the school is 0.064. This is P of A and B. What is the probability of A? The probability that a student takes French is 0.45. If taking geometry and taking French are dependent, what is the probability that a student takes geometry? Now we need to just find this probability of B, condition A. So just take it to the other side and solve. 0.064 divided by 0.45 would be the answer. This would be the answer. That's it. If you know the formula, it is very simple to solve it. So this is how we solve it. Now you can see here they have written this, and you just take this to the other side and divide. So it is 0.14% or 14% chance that the student takes geometry as well. And we move to the last problem. Please try this by yourself. See, all the probabilities are given and you can do it by yourself. Let's just quickly read this. At Bell High School, 43% of students are in an after-school club and 28% play sports. What is the probability that a student is an after-school club if he or she also plays sport? If being in a club and playing sport are independent. Okay, this is very important. Since they have told it's independent event, doesn't matter what is the probability of playing a sport or anything, it's not going to affect the probability of being in the sports club. They're independent. Basically, the probabilities are not going to affect, right? So now, what do we want? The probability that a student is an after-school club? It's obviously 43% because it's regardless of what they play. See, it's clearly mentioned whether they play sports or they're an after-school club activity, they're not affected because they're independent events. So this is again another simple one. And that's it. So please do practice all these problems by yourselves. Go through them again. All the worked out solution is also there. And if you have any doubts, please do post them in the comments and I will get back to you very soon.